With my recap fix having failed, I'm drawing a line undoing them. Hello all and welcome back to the corner. In the last episode on the Mac Classic II repair, we attempted to repair the thin line screen issue with a full recap on the analog and logic boards. With the issue still being present, it's time to delve into the schematics and figure out what is triggering this Mac's vertigo. Whilst I don't have schematics for the Mac Classic II specifically, they do exist for the original Mac Classic, of which the analog board is essentially the same. If we take a look at the Beaumark schematics, we can see that the vertical deflection coil is driven by the TEA2037 drive chip. The schematics also show us what waveform we should expect on the drive output, which is very handy. This second waveform is the powered side and what it should look like too. So to measure this, I've brought out my trusty boat anchor of an oscilloscope. Truthfully, I'm not hugely knowledgeable about scope and the specifics regarding them, but we only need to understand the basics in this instance. But thankfully I was able to find an old video in the archives which happens to explain just how one of these old things works. So, let's take a look.
The oscilloscope is an electronics apparatus built to observe and study the flow of electrons in a given circuit. It has the following controls on its front: the volts per division selector control, the time-based selector control, and finally the offset delay control. These three controls allow the user to observe the flow of electrons in much greater detail than ever before. As a point on the circuit is tested, the oscilloscope measures the point and then using the integrated visualizer, it then draws a representation of the current waveform. But wait, what is a waveform, you ask? A waveform is a line drawn on a screen which changes over time. This waveform is called a square wave. This is because its waves are sharp and look like a square. But there are many different styles of waves, such as sine, triangle, sawtooth, and tidal. Measuring the waveform is done by measuring the wave against the reference grid, with the x-axis for time and the y-axis for voltage. Putting the waveform against this grid allows one to measure both the voltage at any given point in the wave and for how long between waves. This grid is set up so that the voltage measurement is 2 voltaires per division. The time base is set at 200 microseconds per division. Using a line to measure our wave against this grid from the ground reference point, the peak of this wave rises to 2 1/2 lines of the grid. Therefore, at 2 voltaires per division, this wave peaks at 5 voltaires. You can also say that this wave is 5 voltaires from peak to peak. Using another line, we can also measure the time between high and low points of the waveform to find its frequency. This wave measures approximately 4.13 grid lines. At 200 microseconds, this means that the waveform's frequency is approximately 826 microseconds or 2403 cycles per second. We can now use this to measure and record behavior in electronic devices and to troubleshoot malfunctions by comparing to known conditions. Truly a remarkable piece of engineering.
Now we know what an oscilloscope is, let me explain how we're going to use it to diagnose the Mac. Essentially, if we set the controls right, we can look to see if the waveforms described in the schematic are what we see on screen. So for the vertical deflection, we need to see a 60ish Hz peak at around 25 volts on pin 8 of the TEA chip. And on the Mac we get... A quick caution to not do this at home if you don't fully understand what you're doing. There is dangerous voltages on this board and you can harm yourself, possibly fatally, if you touch something wrong. I am taking the proper precautions and making sure I do not risk myself. Now, back to the Mac. Our survey says... Well, there's the problem. We have no output, so of course we're going to have no vertical sweep, because the vertical coil isn't moving the beam at all. And given that we have an input to the chip for the vertical pulse, then it looks like the TEA chip has failed, right? So, let's replace it. The first step of removing the analog board is watching my part 1 where I took the boards out of the machine. Removing the TEA chip is fairly easy as the analog board is single-sided. I just reflowed the pins with fresh solder and then use a desoldering pump to remove the excess solder. To aid removal of the chip without damaging the pads, I used Adrian Black's method of using a heat gun to melt any residual solder. Finally, I cleaned up the holes by soldering them all again and then using a pump to remove the solder to leave clean holes. I was able to source a brand new TEA chip, which is what I'll be using here. Before installing it, I decided to clean the board underneath the chip with some IPA, as when the IC is installed this would be impossible to do. With the chip all soldered in, I've reassembled the Mac just enough to test it. No. Not only was I annoyed by this outcome, but I was also confused. I had thought that the new chip was faulty, but then I decided to double check my measurements. Even going as far as making a custom harness to use the board on an external screen and PSU, which works if you're using a 22kHz capable monitor. Seeing it work meant the logic board should theoretically be fine. Okay, so the situation that we have here is that down here by RF13 we're supposed to be getting 12.6-ish volts, but I'm not getting that, I'm getting like 300 millivolts. I'm looking over here as well, and although the printer hasn't done a good job, these two points are actually connected. This doesn't have voltage either. The only thing I can see that is not working in any of this point is RL2, which is a 1 ohm resistor. Now RL2, sorry for the lack of light, RL2 is that one right there. Now I've just tacked over a 10 ohm resistor onto it because that's the lowest value I have, but I figure considering that RL2 was measuring something like 2K, putting 10 ohm over that should do something different, because I've changed the IC 3 times now and I believe this isn't supplying power to part of the IC. The fact it's not displaying anything is actually a good thing right now. I actually forgot to plug the yoke in, so that wasn't a good idea. Anyway, let's try this again. Well, I'm still not getting anything on the picture, but there is something. If I go to the neck board, we are getting our vertical sweep. So the 10 ohm resistor is doing something, but the monitor is just not showing anything now. Right, it's getting very late into the night, but let's turn it back on. Get the bongs of life. And then if we go to PL2, which is the cutoff, come on. There we go. It's working. Finally, it's working. At least for now.